Welcome to my course, Game Development Basics, Week 5, Lesson 3, Create Screen Constraints. And we showed this in the last lesson, but just to remind you, when the player's ship gets close to the edge of the screen, we want to restrict its ability to go off the screen. And we want to do this for the top, bottom, left, and right. And we want to do this in two ways. First, when the player gets near the edge of the screen, we want to disable the player inputs. And then we also want to create a function to return the ship to the screen when the player goes off screen. So as I said, the first thing we want to do is disable these movement inputs when the player gets near the edge of the screen. So I'm going to start by creating a branch. And then the question is, what should this input be? Well, here I've demonstrated that when the ship gets close to the edge of the screen, in this case, the left edge of the screen, we want to have some function that basically disables that input. This is going to end up being a pretty messy function. So I'm going to start by creating a function. And for this first one, we want to be checking if it's at the top or the bottom of the screen. So I'm going to call this one is at top or bottom of a screen. And let's get a return node. We want to create an output of a Boolean, and I'm going to make this a pure function, and that way we connect it just directly into this branch. And if it is at top or bottom, we want it to stop movement, so we'll connect this to the false. So back in here in our function, how do we check if it's at the top or the bottom of the screen? Well, luckily there's a node for this. So let's start by saying get player controller. If we type in project, we can get project world to screen. And we can see that it takes a few inputs. It takes a player controller input, a world position, and a Boolean. And what this will do, it will take this world position and it will end up giving us position on the screen. So let's get a reference to our player ship and say get world location. And we can plug this screen position output, which if we look at it, it's a vector 2D. It's a variable that has two floats. And we can see this by pulling off and saying break vector, and we see we have an X and a Y coordinate. And this is the X and Y coordinate on the screen. And it's worth noting here that when we refer to these coordinates, 0 and 0 start in the top left corner. So the corners of our screen are 0, 0, top right would be the X resolution and 0 for Y, X resolution, Y resolution, and then 0 for X and Y resolution. And this takes into account the resolution of the viewport. So we can test this by creating a print string here and just dragging this in. And now if we look, we can see that it's giving us the X and Y coordinates of where our ship is. And if we move around, those coordinates change. And so the top left should be 0, 0. And the bottom right should be about the resolution of my screen. Let's delete this print string. And now what do we want to do? Well, this is our top and bottom check. So we want to check if Y is less than 0 or if Y is greater than. And for this, we're going to want the resolution of our screen. There's also a node for that. We can use get viewport size. And we can also break this and pull this Y into there. And now, no matter the resolution of the player's screen, we're always going to be checking if we're at 0, which would be the top, or the Y resolution of the screen, which would be the bottom. And we can do this with an OR and plug this in. And let's test this out. Now when I go to the top of the screen, I should stop moving. And we can see that we do stop moving, but then we get stuck. And the same is on the bottom. We can get to the bottom, but then we get stuck. And this is because we've now reached the edge of the screen, which means we've disabled our input. What we'll actually need is a way to get the ship back onto the screen when this condition happens. But before we do that, let's set up a similar function to check if we're at the left or right. And this will be a little mini challenge. So using the function that we did to set up top or bottom, let's try to set up the same thing for left or right. If you want to attempt this challenge on your own, you can pause the video now, otherwise I'll show you how to do it. And just a quick tip, we're going to use pretty much the exact same code as here, but we'll use the X instead. So now we can see that this is working. For my is at left or right or screen, I use the exact same code, so project world to screen, taking an input of my player controller, and then the world location of my player ship. I'm taking the X vector and checking if it's less than 0 or greater than the X viewport size, and if either of those are true, then we will throw true here. Similarly with the is at top or bottom of screen, I'm using project world to screen, which will use the get player controller and the world location of my player ship. And then I'm taking the Y coordinate of that and checking if it's less than 0 or greater than the Y viewport size. And if either of those are true, we'll throw true and we'll disable our controls. The last thing we'll need to do is create some functionality to bump the ship back onto the screen when it goes to the edge. Otherwise, we'll just get stuck on the edge of the screen. And for this, I'm going to create another new function. And this is going to be called keep ship on screen. And this is a point where I think that there's more than one way to go about this. I'll show you the way that I found that I think works best, but you may be able to find a better way. And if you do, please feel free to leave a note in the comments about how you achieved this. Now, we're going to have to make multiple checks. We're going to have to check for the left, right, top, and bottom. And for each of these conditions, we're going to have to move the ship in a different direction, meaning the opposite direction that puts it back onto the screen. Let's start with the left and right ones. So we'll create a branch, and for this we can use the function that we already set up, is at left or right of screen. And I'll create another function, and I'm going to call this one bump left right. And let's just drag this and put it right onto the true here. Now here we're going to want two different conditions. If we're at the left of the screen, we want to move it to the right, and if we're at the right of the screen, we want to move it to the left. So we'll start with a branch, and this is going to be the left or right movement. And to check whether we're at the left or right of screen, let's grab all this code that we've already set up. If we're all the way to the left of the screen, we know that our X value is going to be 0 or less than it. So if our X value here is less than or equal to 0, this will give us our true function. And if it's greater than or equal to 0, we know that it's likely on the right side of the screen. So let's get this player ship and get world location, and we'll copy it over here. And off here, off of our capsule, I'm going to say set world location. And we'll take this get world location and we want to add a value to it. We can plug this in here. What do we want to add? Well, we could take our same component and say get right vector and then some distance to the right, and we can create that distance by using a multiplication node. And we can change this bottom pin to an integer and then type some number. Let's start with something small like 20 to see where that gets us. So just to recap what we have so far, we're getting the world location of our player's ship and we're projecting that to the screen. We're taking the X value, and if it's less than or equal to 0, we're going to set world location, and we're going to set it to a new location, which is some unit to the right of its current location. The last thing we need to do is call this function, and I think the best place to call this is on the event tick. And there we'll see when we try to go off the left side of the screen, it continually pushes us back onto the screen, and we can no longer get locked in that direction. But for the other three directions, we still can. So we need to set this up as well. since we're already in the bump left or right, let's create the condition for the right side. And we can do all of the same stuff here, but instead we'll want to go -20. And before we do that, we might as well just set this as a variable. And for this, we can use a local variable. And we'll call this bump amount. And on the bottom side, we'll multiply it by -1 and plug it into here. Now, if we get to the right side of the screen, we'll set world location and we'll move the ship slightly to the left. And we can see that that's working. So this works if we're at the left or the right of the screen. We'll call bump left right, and that will move the ship back onto the screen. Let's pull off this false pin and create another branch. And let's create another function, and we'll call this bump ship up. And for this, we want to do pretty much the same thing, but we want to use the forward vector instead. And there we have it. Now our ship can no longer leave the screen. But let's review really quick, because I know we covered a lot. We started by disabling our ship's input when we were at the top or bottom or left or right of screen. And we did this for top and bottom by finding the location of our ship, deprojecting world to screen, and finding that position. We took the Y position, and if it was less than 0, or greater than the Y screen resolution, we call true here. And that would disable move ship up. And we did the same for is at left or right of screen, but using the X axis. Then we set up this function called keep ship on screen, and this is being called on the event tick. And this does the same check, is at left or right of screen, and if it is, then we bump left or right. And in here, we're doing a branch, checking if we are if the X is less than or equal to 0. If it is, we bump it to the right. And to do this, we find the right vector and then add an amount called bump amount to move it back onto the screen. And if it's at the right side, we do the opposite of this by timesing it by -1. And this bumps it back to the left. If it is at the top or bottom of a screen, we call this bump ship up function. And this should actually be called bump ship up down. And in here, we're again checking to see if we are at 0 or less on the Y axis. If we are, we're bumping it down by finding the forward vector and moving it slightly down from that. And if we're at the bottom, we're getting the forward vector and moving it slightly forward in that direction. And this will prevent the ship from leaving the screen. So now that our ship can move around the screen and we can't leave the screen, it's a good time to start moving our camera through the world. And we'll do this in the next lesson.